Design of Spherical Geneva mechanism. There are 9 languages you can choose from the audio track. Go to Setting and select your preferred language audio track. The link for the Chinese version is in the description. Also, you can enable auto-translate to select your preferred subtitle too. I have included the link to download the FreeCAD file in the description if you want to try. The Geneva mechanism is a widely used device for producing intermittent rotary motion, characterized by alternate periods of motion and rest with no reversal in direction. It is also used for indexing, which involves rotating a shaft through a prescribed angle. In contrast, the Spherical Geneva mechanism is very rarely used. In the simplest form, the driven sphere has 4 slots and hence for each rotation of the arm, the sphere advances by one step of 90 degrees. Anyway, it is a good example for Assembly 4 workbench with intermittent motion that cannot achieve by the default assembly workbench in FreeCAD 1.0. These are the major dimensions of the Spherical Geneva mechanism. The idea is using an 75 mm arm at 45 degrees with a pin to drive a sphere with radius of 75 mm. The pin moves along the slots at the sphere to turn the sphere. The semicircular structure at the arm is used to stabilize the sphere when the sphere is not turning. Once I decide the radius of this structure, I can start to construct it and only simple calculation is needed. Then I will set up the relationship between the motions of the arm and the sphere. So I can apply it in Assembly 4 for the simulation. Create a new file. Create a new body and rename it. Create a sketch. Select XY plane. Draw 2 centered arcs. Draw a straight line to join these 2 arcs. Set the radius as 65 mm. The other one is 75 mm. Set these 2 points at the same level. Use polyline to draw the shape. Set this line as vertical. Select these 2 points and set the vertical distance as 75 mm. Horizontal distance is 10 mm. Also 10 mm for this one. The edge of semisphere is 75 mm from the bottom. Make revolution. Remove the reversed option. It is not necessary. Create a new sketch, select XY plane. View section. Draw a slot. Get external geometry. Snap the center to the edge. Set the radius 7.55 mm. Define the length as 51 mm. Cut the space. Select Through All. Select the pocket. Apply polar array. Occurrences 4. Change axis as, select reference. Select Y-axis. 4 slots are cut. Create a new sketch. Select XY plane. Close the sketch first. Change the angle to 45 degrees. Change axis Y to 1. And change axis Z from 1 to 0. Go to the sketch. Get external geometry of the edge. Draw a circle. Move the cursor to Y-axis and the edge, and you will see the symmetric sign. Set the diameter as 70.1 mm. Cut the space. Select Through All. Select the pocket. Apply polar array. Occurrences 4. Switch to Select Reference for the axis. Select the Y-axis. 4 semicircular slots are created. Change to wireframe. Hold the Control key and select these edges. Apply fillet. Use 1 mm as radius. Switch back to as is. Select the body. Right-click the mouse to get the menu. Select Appearance. Click Custom Appearance. Select Ambient Color and choose Green. Create a new body and rename it. Create a new sketch. Select XZ plane. Use polyline to draw the shape. Use dimensioning tool. Set this line as 25 mm. This line is 5 mm. This line is also 5 mm. This point is 35 mm from the origin. Select these points and set the distance as 5 mm. Make revolution. Change to Select Reference. Select X-axis. Create a new sketch. Select XY plane. Switch to construction line. Draw a straight line from the origin. Select the X-axis and the line. Set the angle as 45 degrees. Set the length as 75 mm. Just to constrain the drawing, and the length is not important. Get external geometry of this line. Switch to normal drawing mode. Draw a rectangle. View section. Snap the corner to the edge. Snap it also to the construction line. Use dimensioning tool. Set the length as 8 mm. This one is 17 millimeters. Cut the space. Select Through All. Symmetric to plane. Create a new sketch. Select XY plane. Get external geometry of this line. Use polyline to draw the shape. Select the x-axis and this line. Set the angle as 45 degrees. Select these two lines and make them parallel. Make these two lines perpendicular. Select the origin and this point. Set the distance as 90 millimeters. Extrude. Symmetric to plane. Length is 36 millimeters. Select this surface. Create a new sketch. Draw a circle at the x-axis. Diameter 15 millimeters. Get external geometry of the edge. The center is 15 millimeters from the edge. So, this pin is 75 millimeters from the origin. Extrude. Length is 10 millimeters. Select this surface and create a new sketch. Get external geometry of the circle. Draw two centered arcs. Draw straight lines to join these two arcs. Make the arc and the circle equal. Set this line as 5 millimeters. Extrude. From the drawing, the length of this section is 75 divided by the square root of 2, minus 30, minus 1.7. To make it a little bit shorter, we'll minus 32 millimeters instead. So, length is 75 times 0.70711 minus 32 millimeters. Select the circle. Apply fillet, radius 1 millimeter. Select these two lines. Apply fillet. Radius 17 mm. Select these four edges. Apply fillet. Radius 1 mm. Select the body. Right-click the mouse to get the menu. Select Appearance. Click Custom Appearance. Select Ambient Color and choose Blue. Select the file Spherical Geneva. Switch to Assembly 4 Workbench. Create assembly file. Parts folder and assembly file are created. Components are now in the parts folder. Hide the body. Add variable. Name it angle. Set initial value as 0. Select the assembly file. Create a new sketch. Call it Master. Go to Model and select LCS Origin as reference. Return to Task Panel. Select Plane Face. Open the sketch. Draw two lines. Use Dimensioning tool. 75 mm for the vertical line. For the horizontal line, enter 75 times square root of 2. Create new coordinate system. Name it as M1. Select the short line. Click Z tangent to edge. LCS is created, but I want to move it to the other end. Select the end of the line. Then the LCS moves to this end. Create new coordinate system again. Call it M2. Select the long line and Z tangent to edge. Click the end to move the LCS there. Hide the assembly by pressing the space bar. Show the body sphere. We'll create the LCS at the bottom. Create new coordinate system. Select the circle and concentric. Hide the sphere and show the body turn. Go back to Assembly 4. Select the body. Create new coordinate system. Select the circle and concentric. Hide the body. Show the assembly. Insert part. File information is not updated. Cancel the operation. Save and close the file. Reopen the file to update the part list. Insert part now. Insert the part, sphere. Select parent assembly. Match M1 to sphere C. Insert the part, turn. Select parent assembly. Match M2 to turn C. Rotate about Y twice. And then rotate about Z. Select the part, sphere. Change the angle to 45 degrees. Now the pin match the position of the slot. In this drawing, the left-hand side represents the motion of the arm. The right-hand side represents the semisphere. The arm rotates on a vertical plane while the sphere turns on a horizontal plane. The common length, L, relates the motion of arm and the sphere. Although the line, L, does not actually connect the arm and the slot at the sphere, the horizontal distance traveled by the arm and the slot must be exactly the same. From the calculations, angle B is 45 degrees minus arctangent of cosine A. When A is from 0 to 180 degrees, the sphere is stationary. Starts from 180 degrees, the sphere turns according to angle B. So the conditional expression for the motion of the sphere is variables.angle is greater than 180, question mark. 45 degrees minus arctangent of cosine variables.angle. Colon. 0. Go to LCS, turn C. At angle, click the expression engine icon. Enter variables and select angle. Go to sphere C. At angle, click the expression engine icon. Enter the conditional expression. Run the animation. The variable is angle. Begin from 0 and end at 360. Step size is 5. The sphere does not rotate. The angle didn't change. Open the expression editor and there is error for the unit. Enter unit, degree, after 45. The problem is fixed. Run the animation again. The rotation direction is wrong. Stop it. Go to LCS, Sphere C. Change the value to negative. Run the animation. It is good now and the arm drive the sphere. Change the step size to 10 and try again. Hide the LCS. Hide the master sketch. Please subscribe and give it a like. Thank you for watching.